This video is to accompany the Cisco Netacad CCNA Switching, Routing, and Wireless Essentials course. We will be looking at configuring a switch with the initial settings, configuring switch ports, securing remote access, basic router configuration, and verifying directly connected networks. Configure a switch with initial settings. After a Cisco switch is powered on, it goes through the following 5-step boot process or boot sequence. The first step is the switch loads a power on self-test or post. It's a program stored in the read-only memory. And the post checks the CPU subsystem. It tests the CPU, the RAM, and a portion of the flash device that makes up the flash file system. The next step is the switch loads the bootloader software. The bootloader is a small program stored in ROM or read-only memory that is run immediately after the post successfully completes. The third step is the bootloader performs the low-level CPU initialization. It initializes the CPU registers, which control which physical memory is mapped, the quantity of memory, and its speed. And then on the fourth step, the bootloader initializes the flash file system of the system board. And finally, the bootloader locates and loads a default iOS operating system, and that is put into memory, and it gives control of the switch over the iOS. The switch then attempts to automatically boot by using information in the boot environment. If this variable is not set, the switch attempts to load and execute the first executable file it can find. And the iOS operating system then initializes the interfaces using the Cisco iOS commands found in the startup config file. And the startup config file is called config.txt, and it's located in the flash. In the example below, the boot environment variable is set using the boot system global configuration mode. And notice that the iOS is located in a distinct folder, and the folder path is specified. And if you use the command show boot to see what current iOS boot file is set to. In the command boot system, that's the main command. Flash is the storage device. This name right here is the path, and this name right here is the iOS file name. The switch LED, light emitting diode indicators, they show the system is receiving power and functioning properly. That's the system LED. The RPS, or the redundant power supply, shows the RPS status. The port status, when it's green, it indicates the port status mode is selected, which is the default. And then the port status can then be understood by the light associated with each port. The port duplex LED, when it's green, indicates the port duplex mode is selected, and port duplex can then be understood by the light associated with each port. The port speed LED, when that is green, indicates the port speed mode is selected, and the port speed can then be understood by the light associated with each port. And the power over Ethernet, or PoE, if it's present if the switch supports PoE, it indicates the PoE status of the ports on the switch. And the mode button is used to move between the different modes: stat, duplex, speed, and PoE. This is a chart that shows you each of the modes, and if it's off, if it's on, if you get a blinking green, if you get an amber light, a blinking amber light, or an alternating green and amber light, what their meanings are. Now, when a device recovers from a system crash, the bootloader provides access into the switch if the operating system cannot be used because of missing or damaged system files. The bootloader has command line that provides access to the files stored in flash memory, and the bootloader can be accessed through a console connection following these steps. You first want to connect a PC by console, configure terminal emulation software to connect to the switch, unplug the switch power cord, reconnect the power cord to the switch, and you want to leave it off for, I would say, at least 30 seconds to a minute. Just give it a time to power down, and then power back up when you plug it back in. You want to press and hold down the mode button while the system LED is still flashing green, and then continue pressing the mode button until the system LED turns briefly amber and then a solid green. Then you want to release the mode button. The bootloader switch prompt appears in the terminal emulation software on the PC. The bootloader command line supports commands to format the flash file system, reinstall the operating system software, and recover a lost or forgotten password. For example, the dir command can be used to view a list of files within the specified directory. So to prepare a switch for remote management, the switch must be configured with an IP address and a subnet mask. To manage the switch from a remote network, the switch must be configured with a default gateway, and that's very similar to configuring the IP address information on host devices. Here you see we're taking the PC, connecting a console cable, and this is using Packet Tracer into the switch, and then we have a direct line over to the, and I need to erase that because I did not mean to mark over. We have a direct line over to the router, the default gateway. In the figure, so the switch virtual interface, or SVI, on S1 should be assigned an IP address, and the SVI is the virtual interface, not a physical port on the switch. A console cable is used to connect to a PC so that the switch can be initially configured. Now, by default, the switch is configured to have its management controlled through the VLAN 1, and all ports are assigned to VLAN 1 by default. For security purposes, it's considered a best practice to use a VLAN other than VLAN 1 for the management VLAN. And in step 1, you want to configure the management interface. From the VLAN interface configuration mode, an IPv4 address and subnet mask is applied to the management SVI of the switch. The SVI for LAN 99 will not appear as up until VLAN 99 is created and there's a device connected to the switch port associated with the VLAN 99. And there's a note here that the switch may need to be configured for IPv6. For example, before you can configure v6 addressing on a Cisco Catalyst 2960 running the iOS version 15, you'll need to enter the global configuration command, SDM, prefer dual IPv4 and IPv6 default, and then reload the switch. Here's a chart for the configuration example. You can enter global configuration mode with config terminal, interface configuration mode for the SVI, interface VLAN v99 or VLAN 99, set the IP address, set the v6 address, do the no shutdown to make sure it's up, return to privilege mode, and then copy the running config to the startup config. Step 2, you want to configure the default gateway. The switch should be configured with the default gateway if it will be managed remotely from networks that are not directly connected. And that's because it will receive a default gateway from a router advertisement or RA message. The switch does not require a v6 default gateway. You can enter config mode, config terminal, IP default gateway, set the v4, click in to return to privileged exec, and then copy from the running config to the startup config. Step 3, you want to verify your configuration. The show IP interface brief and show v6 interface brief, and I'm not saying IP every time because it's just easier for me to say v6, by the way. The commands are useful for determining the status of both physical and virtual interfaces. The output shown below confirms that the interface VLAN 99 has been configured with a v4 and a v6 address. And a note here is that the address applied to the SVI is only for remote management to the switch. It does not allow the switch to route layer 3 packets. 1.2, configuring switch ports. Duplex communication. Full duplex communication increases bandwidth efficiency by allowing both ends of a connection to transmit and receive data simultaneously. That's also known as bidirectional communication, and it requires microsegmentation. A microsegmented LAN is created when a switch port has only one device connected and is operating in full duplex mode. There's no collision domain associated with a switch port operating in full duplex mode. And unlike full duplex mode or duplex communication, half duplex communication is unidirectional. Half duplex communication creates a performance issue because data flow can only go in one direction at a time, often resulting in collisions. And gigabit Ethernet and 10 gigabit NICs require full duplex connections to operate. In full duplex mode, the collision detection circuit on the NIC is disabled, and full duplex offers 100% efficiency in both directions, both transmitting and receiving, and this results in a doubling of the potential use of the stated bandwidth. Switch ports can be manually configured with specific duplex and speed settings. The respective interface configuration commands are duplex and speed. The default setting for both duplex and speed for switch ports on the 2960 and the 3560, it's automatic. The 10, 100, 1000 ports operate in either half or full duplex mode when they're set to 10 or 100. and they operate only in full duplex mode when it's set to 1000 megabytes or 1 gig. Auto negotiation is useful when the speed and duplex settings of the device connecting to the port are unknown or may change, and when connecting to known devices such as servers, dedicated workstations, or network devices, a best practice is to manually set the speed and duplex settings. So when troubleshooting switch port issues, it's important that the duplex and speed settings are checked. That's one of the first steps. Mismatched settings for the duplex mode and speed of the switch ports can cause connectivity issues, and auto negotiation failure creates mismatched settings as well. And then a note here below, all fiber optic ports such as 1000 base SX ports operate only at one preset speed and are always full duplex. This is an example here where you have full duplex mode for 100 megabits between the two switches, and the commands here are below to check those. Now, auto MDIX, when automatic medium dependent interface crossover, auto MDIX, C for crossover, X is for crossover, by the way. So automatic medium dependent interface crossover, or MDIX, is enabled. The switch interface automatically detects the required cable connection type, either a straight through or a crossover, and configures the connection appropriately. And when connecting to switches without the auto MDIX feature, straight through cables must be used to connect the devices such as servers, workstation, or routers. Crossover cables must be used to connect other switches or repeaters. With auto MDIX enabled, either type of cable can be used to connect to other devices, and the interface automatically adjusts to communicate successfully. On newer Cisco switches, the MDIX auto interface configuration mode, that command enables the feature, and when using that MDIX on an interface, the interface speed and duplex must be set to auto so that the feature operates correctly. And then a note is the auto MDIX feature is enabled by default on the 2960 and 3560, but it's not available on older 2950s or 3550 switches. And then to examine the auto MDIX setting for a specific interface, you want to use the show controllers Ethernet-controller. And that command is with the PHY keyword. To limit the output lines to referencing auto MDIX, use the include auto MDIX filter. And you can the switch verification commands are here. You can display, show interfaces, show startup, show your run config, show your flash, show your version or show ver, show history, show your IP interface, show v6 interface, show your MAC, or show your MAC table. The show run config command can be used to verify that the switch has been correctly configured. From the sample, the abbreviated output on S1, some important information is shown in the figure. You see fast Ethernet 018. It's configured with the management of VLAN 99, and the VLAN 99 configured with a v4 address of 172.17.99.11, 255.255.255.0, and the default gateway set to 172.17.99.1. So we see our IP address, we see our subnet, and then we see our v6 address, and then we see our IP default gateway. The show interfaces command is another common use command. It displays status and statistics on the network. The show interface command is frequently used when configuring and monitoring network devices. And so the example below, the output show interface fast Ethernet 018 command indicates that the fast Ethernet 018 interface is up, meaning that it's operational. And then we can look that the output shows that the duplex is full and the speed is 100 megabits. So we see that it's up, we see the speed, we see the address, we see other important information. We see the keep alive, we see the full duplex, the speed, and the media type. The output from the show interfaces command, it's also useful for detecting common media issues. One of the most important parts of the output is the display of the line and the data link protocol status, as shown in the example below. The first parameter refers to the hardware layer, and it indicates whether the interface is receiving a carrier detect signal. The second parameter, the line protocol up, refers to the data link layer, and it indicates whether the data link layer keeps alive or being received. The protocol keeps alive or being received. And then based on the output of the show interfaces command, Possible problems can be fixed as follows. If the interface is up and the line protocol is down, you have a problem. There could be an encapsulation type mismatch, the interface on the other end could be error disabled, or there could be a hardware problem. And if the line protocol and the interface are both down, a cable is not attached properly, or you may have some other type of interference. For example, it's back-to-back communication, the other end may be administratively down, and so you'll need to go to the other end or have somebody check the other side. And if the interface is administratively down, it's been manually disabled or the shutdown command has been issued in the active configuration. So we can see our connection, we can see our hardware, our address. The show interfaces command output on the right displays counters and statistics for the interface as shown. And I'll just pause here for a second so you can see this interface information. Some media errors are not severe enough to cause the circuit to fail, but they do cause network performance issues. And the table below explains some of the common errors that can be detected using the show interface command. You can get input errors. That shows the total number of errors. Runts are packets that are discarded because they're smaller than the minimum packet size for the medium. An Ethernet packet that is less than 64 bytes is considered a runt. Giants are packets that are discarded because they exceed the maximum packet size. For example, one that's greater than 18 bytes is considered a giant. A CRC error is generated when the calculated checksum is not the same as the checksum received. And then output errors are the sum of all errors that prevented the final transmission of datagrams out of the interface that's being examined. And collisions are the number of messages retransmitted because of an Ethernet collision. And then late collisions are a collision that occurs after 512 bits of the frame have been transmitted. Internet errors is the sum of all errors in datagrams that were received on the interface. That includes runts, giants, CRC, no buffer, frames, overruns, ignored counts as well. And the reported input errors from the show interfaces command include the following: runt frames, giants, and CRC errors. They also include collisions and late collisions. Here we have a flowchart on troubleshooting network access layer issues. We do a perform show interfaces, and is the interface up? If we check that, if the interface is up, then we need to check for EMI noise. If there is EMI noise, we need to trace the line and figure out where that is and remove that. Verify the duplex setting is properly set on both ends. And then what goes down is the problem solved. If it's solved, yes, we're done. Whoops, and we're done. If we go back up and we say that is the interface up and it's not, then we need to verify that we have proper cables. We need to check the cables and connectors for any damage. Verify speeds if it's properly set on both ends. And then if that's still not working, then we need to document the work done and escalate the issue up to the next tier. Securing remote access. Telnet uses a TCP port 23. It's an older protocol. It uses an unsecured plain text transmission of both the login authentication, username and password, and the data transmitted between the communicating devices. In other words, it's not good to be using it, so if somebody's sniffing your traffic on your local area network, they're going to be able to see everything in plain text. A threat actor can monitor packets using a program like Wireshark, and they can capture your username and your password from a Telnet session, and that's what we're seeing right here on the Wireshark. Someone's seeing that the admin information is going through and then the password. And then now they'll be able to connect to the router in this case and put in their username and password and gain control. So what you want to use is Secure Shell, or SSH. It's a secure protocol that uses port 22. It provides an encrypted management connection to a remote device. And SSH should always be used instead of Telnet for the management connections. SSH provides security for remote connections by providing strong encryption. So the username and password are put into an encrypted, and you can see on the right-hand side here, they only see the hash information. And so this figure here, it's captured the SSH session, but the threat actor can track the session, but they'll need to decrypt this if they are going to see the information. You can verify that the switch supports SSH. To enable SSH on a Catalyst 2960, the switch must be using a version of the iOS software including cryptographic encrypted features. Use the show version command on the switch to see which iOS switch is currently running. An iOS file name that includes the combination K9 supports the cryptographic encrypted features and capabilities. Now to configure SSH, The switch must be minimally configured with a unique host name and the correct network connectivity settings. So you want to verify your SSH support. Use the IPSSH command to verify that the switch supports SSH. If the switch is not running an iOS that supports cryptographic features, this command is unrecognized. Next, you're going to configure the IP domain. Configure the IP domain name of the network using the IP domain name global configuration mode command. Then you're going to generate RSA key pairs. You can do that automatically enabling SSH, or generating a key pair automatically enables SSH. And then use the crypto key generated RSA global configuration mode command to enable SSH server on the switch and generate your key pair. Now, to delete the RSA key pair, you want to use the crypto key zeroize RSA global configuration mode command. And then after the RSA key pair is deleted, the SSH server is automatically disabled. And then you would just run it again to turn it back on. Then to configure user authentication, the SSH server can authenticate users locally or using an authentication server. To use the local method, you want to create a username and password pair using the username secret password global configuration mode command. And then configure the VTY lines. Enable SSH protocol on the VTY lines by using the transport input SSH line configuration mode command. And then use the line VTY global configuration mode command. And then the login local line configuration mode command to require local authentication for SSH connections. And then finally, on step 6, you want to enable SSH2 or SSH version 2 by default. SSH supports both versions 1 and 2. And then when supporting both versions, this is shown in the show IP SSH output as supporting version 2. And then enabling SSH version using the IPSH version 2 global configuration command will make sure that that's turned on. On a PC, an SSH client such as PuTTY is used to connect to an SSH server. For example, assume the following is configured. The SSH is enabled. The interface VLAN SVI with IPv4 address on switch 1. And then PC1 has an IPv4 address of this. So using a terminal emulator, you initiate an SSH connection to the SVI VLAN IPv4 address. And then when connected, the user is prompted for a username and password is shown in the example below. Using the configuration from the previous example, the user admin and password CCNA are entered, and after entering the correct information, the user is connected via SSH to the command line interface on the 2960 switch. Then to display the version and configuration data for SSH on the device, you can use the show IP SSH command, and that's the example that we get here below. Basic router configuration. When you configure the basic router settings, Cisco routers and Cisco switches have many similarities between them. They support a lot of the same modal operating system, similar command structures, and many of the same commands. In addition, both devices have similar initial configuration steps. For example, the following configuration task should always be performed. Name the device to distinguish it from the other routers and configure passwords as shown in the example below. So we config term, set our host name, we enable secret class, we set the line console 0, we set the password to Cisco, we turn the login on, we exit out, we set line VTY04 through 4, set the password to Cisco, set the login on, exit back out, and then we turn on password encryption. Next, we're going to configure a banner to provide legal notification. And this one's just saying our message of the day is, and we're putting $signs on each side to let us know that this is the message of the day. And then we can say authorized access only, or whatever other banner that you're going to put in there. Just make sure that it has somewhere in there that authorization or authorized access only, or only authorized users are allowed to connect. And yes, that's not going to keep a hacker out or somebody that's going to connect from an illegal standpoint. But as you've probably had a discussion in your previous course with this CCNA, is that this is for legal protection, so that in a court of law that you can say that yes, no one should have been able to get into this without authorized permission, and nobody can claim that I didn't know I wasn't supposed to be in there. Well, they did know because they get this message of the day. Next, you want to save the changes on the router by copying your run config to your startup config. Now on dual stack topology, one distinguishing feature between switches and routers is the type of interfaces supported by each one. So for example, a layer 2 switch supports LANs, and therefore they have multiple fast Ethernet or gigabit Ethernet ports, and the dual stack topology in the figure is used to demonstrate the configuration of a router V4 and V6 interfaces. So if we look at the switch here, we've got both our V6 and our V4. Down here, we've got our V4 and our V6. And then we can display just our abbreviated IP addressing. Same thing for all of these here. Now, when we configure our router interfaces, routers support LANs and WANs, and they can interconnect different types of networks. Therefore, they also support many types of interfaces. For example, G2 ISRs have 1 or 2 integrated gigabit Ethernet interfaces and high-speed WAN interface cards, or HWIC, to accommodate other types of network interfaces, including serial, DSL, and cable interfaces. And then to be available, an interface must be configured with at least one IP address, and you can use the IP address. This is your IP address, set your subnet mask, and the V6, your IV6 address, or IPv6 address, to interface configuration commands, and then make sure they're activated. You want to run the no shutdown command to make sure that they're turned on. And then the description, the interface could also be configured with a short description of up to 240 characters. And it is good practice to configure a description on each interface. On production networks, the benefit of an interface descriptions are quickly realized as they're helpful in troubleshooting and identifying a third-party connection and contact information. This example here shows the configuration for the interface on an R1. You can pause the video. Now on V4 loopback interfaces, another common configuration is enabling a loopback interface. The loopback interface is a logical interface that's internal to the router. It's not assigned to a physical port, and it can never be connected to any other device. It's considered a software interface that's automatically placed in an up state as long as the router is functioning. The loopback interface is useful in testing and managing a Cisco iOS device because it ensures that at least one interface is always available. For example, it can be used for testing purposes, such as testing internal routing processes, emulating networks behind the router. Now, loopback interfaces are also commonly used in lab environments to create an additional interface. For example, you can create multiple loopback interfaces on a router to simulate more networks for configuration practice and testing purposes. And the V4 address for each loopback interface must be unique and unused by any other interface. And in the curriculum we're studying, we often use a loopback interface to simulate a link to the internet. So below is here we set our interface loopback, our number, and then IP address, and we set that with the subnet mask. Verify directly connected networks. There's several show commands that can be used to verify operation and configuration of an interface. The show IP interface brief and the show V6 interface brief. These display a summary for all interfaces, including the V4 or V6 address. The show run config interface is interface ID, and that displays the commands applied to the specific interface. The show IP route and show IPv6 route, those display the contents of the V4 or the V6 routing table that's stored in RAM. And in the iOS 15, active interfaces should appear in the routing table with 2 related entries identified by code C, connected, or L, local. And then in previous iOS versions, only a single entry with the code C would appear. The output of the show IP interface brief and show IPv6 interface brief commands can be used to quickly reveal the status of all interfaces on the router. And if you want to pause, you can see below we're doing the show IP interface brief, and then we get our information. And then the V6. We can also verify the V6 link local and multicast addresses. The output of the show V6 interface brief command displays 2 configured V6 addresses per interface. One address is the V6 global unicast address. The other begins with FE80, and that's the link local unicast address for the interface. A link local address is also automatically added to an interface whenever a global unicast address is assigned. And below we can see the show V6 interface gigabit Ethernet 000 command. And if you want to pause the video, you can look at that. The output of the show run config interface command displays the current commands applied to the specific interface as shown below. We have show interfaces and show IP interface and show IPv6 interface. This is the show run config interface gigabit for that line, and it shows our current configuration. This one shows our description link, our IP address, our subnet, our negotiation, and our v6. The output of the show IP route and the show v6 route commands reveal 3 directly connected network entries and 3 localhost route interface entries as shown in the example on the right. And you see here we have either our C or our L, and then it gives us our IP address. And then down here we see our v6. A C next to the route within the routing table indicates that it's directly connected. When the router interface is configured with a global unicast address and it's in the up state, the v6 prefix and prefix length are added to the v6 routing table as a connected route. The filter show command output, commands that generate multiple screens of output, by default are paused after 24 lines, and at the end of the paused output, the more text displays. Pressing enter displays the next line, and pressing the space bar displays the next set of lines. If you use the terminal length command to specify the number of lines to be displayed, a value of 0 prevents the router from pausing between screens. And then another useful feature that improves the user experience is the filtering of show output. Filtering commands can be used to display the specific sections of an output. So to enable the filtering command, you enter the pipe, and that's usually right above the enter key on a normal keyboard, after the show command, and then entering a filtering parameter and a filter expression. And there's 4 filtering parameters that can be configured: section, include, exclude, and begin. The command history feature is also useful because it temporarily stores the list of executed commands to be recalled. It's a big time saver. The recall command in the history buffer, you can press Control P or use the up arrow. I typically use the up arrow. The command output begins with the most recent command and scrolls back through those. You just keep repeating the up arrow. And Control N or down arrow takes you back down through. And by default, the command history is enabled, and the system captures the last 10 commands lines in its history buffer. And you can use the show history privileged exec command to display the contents of the buffer. It's also practical to increase the number of command lines that the history buffer records during the current terminal session only. So you use the terminal history size user exec command to increase or decrease the size of the buffer. As a recap, I'm not going to read down through each one of these, but you can pause the screen right here. But this is what we covered in this presentation. This is screen 1. This is screen 2. And this is screen 3. Hope this video was helpful. If you have any questions, please leave a comment below. Hope you have a great day.